There's a lot that I want to get through in this video today, so please bear with me. Okay, the first blank means the measurement of triangles is trigonometry. We have 6 functions: sine, cosine, and tangent, cosecant, secant, and cotangent. The abbreviation for sine is S-I-N. And if you look at your picture on the right, sine of an angle is going to equal opposite over hypotenuse. You can use SOHCAHTOA to help you. So I'm just going to say sine of theta of my angle is equal to opposite over hypotenuse. Abbreviation for cosine is cos, C-O-S. Cosine is adjacent over hypotenuse, so A over H. The abbreviation for tangent is T-A-N. And tangent is opposite over adjacent. Now these other 3 are reciprocals of sine, cos, and tangent. Cosecant is the reciprocal of sine. The abbreviation for cosecant is C-S-C. Now if I told you they're reciprocals, what ends up happening is that you need to flip the fraction. So it's going to be H over O. Secant is the reciprocal of cosine. Its abbreviation is SEC. And you have to flip the secant graphs, or secant fraction, so it's H over A. And cotangent is COT. Cotangent of theta is going to equal adjacent over opposite then. First piece here. I give you the lengths of a triangle. I tell you C is the right angle. Find the measures of the trig functions at angle B. I also tell you that angle A is less than angle B. So let me start by drawing a triangle. It says angle C is my right angle. I'll just call this A and I'll call this B. If A is the smallest angle, then the smallest side is across from it. B is the next. And C is the hypotenuse. We want to find the 6 trig functions at angle B. So looking at this picture, sine of theta is going to be opposite over hypotenuse, so 8/10. Cos of theta is adjacent over hypotenuse, so 6/10. Tan of theta is opposite over adjacent, so 8/6. Cosecant is the reciprocal of sine, so instead of being 8/10, it's 10/8. Secant is the reciprocal of cos, so it's going to be 10/6. And cotangent is going to be the reciprocal of tangent, so it's going to be 6/8. Same idea over here. Okay, we have A, B, C. We have 3 is the largest, so that's going to be the hypotenuse. Radical 2 is the smallest, and radical 7 is the middle. What I want you to do is, in a sec, you guys will finish finding the 6 trig functions of that one. Moving on to the next one, same idea here. Okay, we have, I'm going to draw the triangle in the next problem. It says we have a triangle PQR where R is the right angle. It tells me that PQ is 25. QR is 24, and PR is 7. We want to find the exact value of each trig ratio. So sine of P, so we're going from angle P first up here. Sine of P is opposite over hypotenuse, so it's 24 over 25. Cosine is adjacent over hypotenuse, so 7 over 25. Tangent is opposite over adjacent, so 24 over 7. Cosecant, you have to flip the sine fraction, so it's 25 over 24. Secant, flip the cosine, so 25 over 7. Cotangent, flip the tangent, so 7 over 24. These next 6 are from angle Q instead. So sine of Q is opposite over hypotenuse, so it's going to be 7 over 25. I want you guys to finish the other 5 in that particular question. Okay, the next one says an access ramp reaches a doorway 2.5 feet above the ground. So there's my door. This is my ramp. It says it's 2.5 feet above the ground. The ramp is 10 feet long. What is the sine of the angle the ramp makes with the ground? So I'm looking for the sine of the angle I just drew. Sine of the angle we know is opposite over hypotenuse. So it's 2.5 over 10. I don't really like decimals and fractions together, so 2.5 over 10 is the same as 1/4. And that's it there. A pole perpendicular to the ground is braced to a wire 13 feet long that is fastened 5 feet from the base of the pole. So let's draw that picture over here. Okay. So we have a perpendicular pole, 13 feet long, so 13, fastened to the ground 5 feet from the base of the pole. The measure of the angle wire makes with the ground, that's our theta. We want to find the value of the following. Well, oops, I'm sorry, I read the question wrong. This wire is 13 feet long. It will help us to solve these if we could find the third side of the triangle. You could use your Pythagorean theorem, which I'm not going to show at this point. You could also just know it's a triple. The triple is 5, 12, 13. Alright, secant is the reciprocal of cosine. So if cosine of this triangle is 5 over 13, secant is 13 over 5. Cosecant is the reciprocal of sine. So if sine is 12 over 13, cosecant is 13 over 12. Cotangent is opposite over adjacent. I'm sorry, tangent is opposite over adjacent. So cotangent will be adjacent over opposite, which is 5/12. This next piece is calculator stuff. And what I want you to do right now is turn your calculator on. And you're going to make sure it's in degree mode. And the way you do that is you hit the mode. And you make sure that on the third one down, that degree is highlighted. Okay, if it's highlighted, what you're going to type is sine 28 and enter. And when you do that, you end up getting 0.4695. Right? Cos 75, you could type that in. And you end up getting 0.2588. For the next one, you're going to type tan 88. Now, to get that degree symbol, what you're going to do is second apse, number 1. And then you're going to type 30, and then second apse, number 2. And you end up getting 38.1885. To type cotangent, the way you type cotangent is 1 divided by tan 63. So 1 divided by tan 63 is equal to 0.5095. I'll show you how to type the other ones, and you will type them on your own afterwards. Secant is 1 over cos, and you'll do 72 degrees, 15 minutes. And then for cosecant, it's going to be 1 over sine of negative 375. So those last two in that one, I do want you to try on your own and see if you can get it. Alright, find the smallest positive value of theta to the nearest degree, then find the radian measure to the nearest 10,000th. Okay, do solve these. What this is asking you to do is solve for theta. And we don't have a divide by sine. There's no such thing. So to get theta by itself, we take what's called the inverse, which is sine negative 1. If you look in your calculator, you do have that button. It's the second sine button. So you'll type second sine, and then you'll type 0.3455. And you get 20 point, well, it's nearest degree, so 20 degrees. For cosine, you're going to do inverse cos. So cos negative 1. So you're going to do second cos of 0.9990. And you get 3. I'm going to leave the tangent for you. Just take inverse tan of the other side. For these next ones, it says cosecant is 3.275. What you do is you don't have an inverse cosecant button, so you will take the reciprocal of both sides. The reciprocal of cosecant is sine theta, and the reciprocal of 3.275 is 1 over 3.275. And then from there, it's like the last problems we just did. You're going to take the inverse of both sides. And when you take the inverse of 1 over 3.275, you get 18 degrees. I'll set up the other two with you and have you finish those. Secant, the reciprocal of secant is cosine. The reciprocal of 1.201 is 1 over 1.2001. You'll do inverse cos from there. For cotangent, the reciprocal of cotangent is tangent. And the reciprocal of 0.3325 is 0.3325. And you'll do your inverse tan from there. Next piece is the same thing we've been doing. What you're going to start by doing, the directions are a little bit different, but the start is the same. You're solving for theta, so you're going to take the inverse sine of both sides. When you take the inverse sine of 0.2672, you get about 15.4977. But look at the directions. The directions say to the nearest minute. So to get to the nearest minute, what you're going to do is use your calculator. You're going to type second angle or second apse. Number 4 is your DMS button. And when you type that, it's going to give you a value. Let me type it. Hold on one sec. So inverse sine of 0.2672. And then second apse, number 4. We get something 15 degrees, 29 minutes, and 51.786 seconds. If this value, these seconds, are 30 or higher, think like a clock. If they're 30 or higher, you're going to round this up. So in this case, it is 30 or higher. So theta will equal 15 degrees and 30 minutes. I want you to try the other two in that section, and we will not worry about this problem for today.